Hi guys, welcome to my YouTube channel. Please subscribe, like and share. In this video, we are going to discuss substitution reactions of alkanes. So alkanes, they are organic molecules with a single covalent bond between a carbon and a carbon molecule. And the single covalent bond, we say that they are sp3 hybridized. So an example of an alkane is hexane, ethane, or even bromine, and also so if you have ethane, for example, reacting with a halogen, for example chlorine, in the presence of sunlight, then you're going to get chloroalkane or chloroethane plus hydrogen chloride. So the reaction, the substitution reaction takes place in 3 steps. The first one is initiation, then we have chain propagation steps where the chain is lengthened, and then we have a termination step where now you bring together the radicals to terminate the reaction. So if you take hexane and bromine, for example, and mix them in the dark cupboard, then no reaction will take place. But if you take hexane and bromine, you mix them and leave them in the sunlight, then the reaction will take place, giving you a mixture of bromohexanes, and the bromine color disappears. So we are going to start with initiation step. So in initiation step, you have the breakdown of the bond between chlorine, and chlorine breaks down homolytically, where each of the chlorine atom forming the bond takes 1 electron. So in that case, you form the chlorine radicals. So you have 2 chloride radicals. Then in chain propagation step, that's where you have the radical attacking the alkane. So in this case, for example, if you have ethane plus chlorine, now the chlorine radical, you will get chloroethane plus hydrogen chloride. So in the propagation step, the first thing that happens is breakdown of carbon hydrogen bond. One of the hydrogen fused or bonded to the carbon breaks down homolytically. So once it breaks down homolytically, the hydrogen will take away 1 electron, and then the chlorine will take away the other electron. So an ether radical is formed. That is a radical that has 1 electron. So it is produced, and then it can combine with the chlorine molecule that has been formed, forming a chloroethane. So the next thing in the propagation step, the chlorine atom can attack the radical that has been formed, or even it can also attack another chlorine ethane molecule, forming an ether free radical, and which regenerates another chlorine free radicals, and so on. So for propagation step means very many radicals can be formed. So it is where the chain keeps on growing and growing. So then the lastly, we have chain termination reaction or termination steps, whereby now the radicals come together to form a complete molecule that will not be attacked anymore by a free radical. So where we have a free radical, for example ethane radical plus a chlorine radical, it will form chloroethane, and that reaction is complete. You can also have ethane radical combining with another ethane radical, forming a longer molecule with now the 2 plus the 2 carbon chain, forming a butane. You can also have chlorine radical bonding with another chlorine radical, forming a what? Forming a chlorine molecule, that is Cl2. So so I have the diagram here showing you the initiation step. Initiation step is shown there, whereby the chlorine radical, you have the Cl2 here. So it's chlorine breaking down, one of the chlorine taking one electron and the other chlorine taking another electron, like I have drawn these two diagrams there. So you'll have chlorine radicals there. So that is initiation step, formation of chlorine radical. Then chain propagation step, as I have explained, it's where the chain is growing or getting bigger and bigger. So we have the molecule that is reacting here is ethane plus the chlorine radical. So ethane plus chlorine radical will give us the chloroethane. Here we have the ethane. First of all, the bond between the carbon and hydrogen breaking homolytically. So when it breaks homolytically, you will generate a ethane radical. That means the radical has one electron with it, and then one of the electron will leave with the hydrogen. So then the ethane radical will be attacked by chlorine radical, forming chloroethane plus chlorine radical. Later on, you can also regenerate another radical from the ethane, the one that you formed, chloroethane. Then another hydrogen can move away from the chloroethane, forming a radical again. Chloroethane radical plus hydrogen chloride. The chloroethane radical can also be attacked by a chlorine again, forming 1,2-dichloroethane plus chloride radical. So the reaction can continue and continue for long. So you need to have termination for the reaction to stop continuing. So termination means ending the chain, because the chain can keep on, you can keep on forming a radical, and the radical regenerates to form another radical. So for termination reaction to take place, then you have to bring up two of the radicals that are starting the reactions. So for example, you can have ethane radical plus a chlorine radical forming chloroethane. You can also have ethane radical plus an ethane radical to form a longer chain molecule, which is a butane. Or you can also bring up the chlorine radical plus another chlorine radical to form chlorine. So that's all about substitution reaction in alkanes. Follow me for more videos. Don't forget to subscribe and comment. Bye.